Hello everyone. In this video, we'll be seeing the second method to solve the Lagrange's equation, that is method of multipliers. So the next method to find the solution of Lagrange's equation is method of multipliers. Here there are two type of multipliers. One is single multiplier and next one is double multiplier. Single multiplier, we are choosing some constants corresponding to all subsidiary equation. That is, there are three equating parts are there. So we are taking three multipliers L, M, N. These L, M, N can be any constant values or some functions of x, y, z. So we are going to choose these L, M, N values such that if we multiply L with the first quantity, M with second quantity and N with third quantity, adding that in this manner, the denominator part should become 0. Okay, and in that case, L dx plus M dy plus N dz can be written as 0. Now integrating this one, we can find the solution u is equal to a. So we are going to find the multiplier LMN such that LP plus MQ plus NR is equal to 0. So we'll be getting the numerator value will be equal to 0. And integrating that numerator, we'll be obtaining the solution u is equal to a. So for one question, we can use two set of multipliers to find the two solutions to write the Lagrange's equation solution. So note that if this denominator quantity is not equal to 0 for any LMN, then we have to go for double multiplying method. Double multipliers is nothing but we are choosing two set of multipliers L1, M1, N1 and L2, M2, M2, and in a same equation we are going to write both the things, and then we have to take these two equations, that is last two pairs, to find the solution. So this is double multiplier method. So let us see some problems in this. So here clearly you can observe that this y minus z will be capital P, z minus x will be capital Q, and x minus y will be capital R. So similar to the previous problem, writing subsidiary equation is nothing but dx by P, dy by Q and dz by R. So replacing that, we can write dx by y minus z, dy by z minus x equal to dz divided by x minus y. So now we have to choose one set of multipliers up in such a way that we have to bring the denominator equal to 0. So observe the values in denominator. You can see that plus y is here, and similarly minus y is here. Minus z is here, plus z is here. Minus x is here, plus x is here. So if we add all the denominators, then clearly we'll be getting 0 because plus and negative sign will get cancelled. So for the first one, I'm going to choose the multiplier 1, 1, 1. So that each fraction in this equation 1 will be equal to, that is 1 into dx plus 1 into dy plus 1 into dz. So in denominator, we can write 1 into y minus z plus 1 into z minus x plus 1 into x minus y. So this is nothing but dx plus dy plus dz divided by y minus z plus z minus x plus x minus y. So minus y plus y will get cancelled, minus z plus z will cancel, and minus x and plus x will be cancelled. So this can be written as dx plus dy plus dz divided by 0. Since I am able to bring this denominator as 0, as said in the method, I can write dx by dy plus dz is 0, and then integrating this one, I will be getting, integrating dx is nothing but x, integration dy is nothing but y, and integration dz is z. This is equal to a. So this will be my first solution, u. So that's what written here. Each fraction of 1 will be equal to dx plus dy plus dz divided by 0. So integrating the numerator, I'll be getting x plus y plus z is equal to a. Now I have to choose the next set of multipliers. Observe that if I multiply x here, so I will be getting xy and xz. So next term, can you tell me what I have to do here? So here, observe that x is ah. So in next term, here if I multiply y, so I'll be getting yx, or it can be read as xy. So now I'm going to choose the next set of multipliers. Observe that if I multiply x with the first term, I'll be getting xy. And if I multiply y with second term, I'll be getting minus xy. So this plus xy and minus xy will get cancelled. Similarly, multiplying x with first term gives xz, that is minus xz. So, but here, if I multiply y in second term, this will be yz. So I have to get positive xz and negative yz. So I'm going to multiply z in third term. I'm going to choose the next set of multipliers as x, y and z. So the numerator will be x dx plus y dy plus z dz divided by, straight away I'm going to multiply that. So it is xy minus xz plus yz minus xy plus xz minus yz. This is nothing but if I cancel these two terms, this two terms and this two terms, I can write it as x dx plus y dy plus z dz divided by 0. So the numerator I am going to integrate it x dx plus y dy plus z dx equal to 0. So after integration, we'll be getting x integrated value is x square by 2 and integration of y is y square by 2 and integration of z is z square by 2. I'm going to take this is equal to some constant c1. So this can be written as x squared plus y squared plus z squared equal to 2c1. I'm going to replace this 2c1 by b. So x squared plus y squared plus z squared equal to b. So this is nothing but our solution b. So now to write the required solution, we have to write both u and v. So phi of x plus y plus z, comma x squared plus y squared plus z squared, this will be equal to 0. This is the required solution. So next problem. So this will be our capital P and this is our capital Q and this will be our capital R. So next, writing subsidiary equations, we'll be getting this term. Now we have to find the multipliers. So let us concentrate on, first let us fix that LMN. Then we shall observe the variables x, y and z. So listen here, m, z is here and mx is here. So if I multiply the first term with x and last term with z, I'll be getting xzm and minus xz m. These two will get cancelled. So obviously I'm going to multiply y in the next term. So let us choose x, y, z as our multipliers. So I'll be getting x dx plus y dy plus z dz divided by, straight away I'm going to multiply everything. It is m xz minus n xy plus n xy minus l y z plus l y z minus m x z. So this term and this will get cancelled. These two will get cancelled and these two will get cancelled. So ultimately I am getting x dx plus y dy plus z dz divided by 0. As said in previous problem, we can write the numerator term x dx plus y dy plus z dz will be equal to 0 After integrating, I can write x squared plus y squared plus z squared equal to a. This is nothing but the first solution u. So see it, denominator I am getting it as 0, and after doing integration I will be getting x squared plus y squared plus z squared is equal to a. Now I am going to choose the next set of multipliers. Now fix z terms, I mean x, y, z terms, we shall concentrate on L, M, N. So if I fix z here and another z term is here. So I am going to multiply the first one with L and second one with M. So L, M, Z, L, M, Z. Positive and negative sign will get cancelled. Since L and M are in first two parts, I am going to take N for the third part. So choosing L, M, N as multipliers, each fraction of 1 will be equal to, so it is L dx plus M dy plus N dz divided by, so I can write it is LMZ minus LNY plus LNX, I mean it is plus MNX minus LMZ plus LNY minus MNX. So this one and this one will get cancelled. These two will get cancelled and these two will get cancelled. So I'm getting L dx plus M dy plus N dz divided by 0. So this implies I can write L dx plus M dy plus N dz equal to 0. Now doing integration, all the terms L, M, N are constants. So I'm going to keep the constant as it is, and integrating dx I will be getting x. M is constant, integration of dy gives y. N is constant, integration of dz is z. So this is equal to some other integrating constant b. I'm going to take this as my next solution b. At last, writing the required solution, we can write it as phi of x squared plus y squared plus z squared, comma lx plus my plus nz is equal to 0. And next problem. So observe this one. We'll be getting this as capital P, this one as capital Q, and this one as capital R. We all know how to write the subsidiary equation. Now I am going to choose the multipliers. So observe, if I multiply x inside, I will be getting xy squared. And if I multiply y inside, this is nothing but minus x squared y. So if there is one more x here and one more y here, these two terms will get cancelled. So I'm going to multiply the first with x and second with y. So obviously the third one with z. So choosing the set of multipliers as x, y, z, I'll be getting dx plus, that is x dx plus y dy plus z dz divided by, so straight away I'll be multiplying everything. So I'll be getting x square y square minus x square z squared plus y square z square minus x square y square plus x square z square minus y square z square. So this term and this term will get cancelled. This one and this one will get cancelled. This one and this one will get cancelled. So I am getting x dx plus y dy plus z dz divided by 0. So this implies I can write the numerator is equal to 0. Now the integration is as similar to the previous problem. After integration, we will be getting x squared plus y squared plus z squared equal to a. This is our first solution u. And next one, suppose if I am removing this x and y, what will happen? This minus z square will get cancelled, and if I remove this z also, x square minus z square plus z square y square, everything will get cancelled. So I am going to choose the multipliers as 1 by x, so that x and denominator x will get cancelled. So choosing 1 by x, 1 by y and 1 by z as multipliers, we'll be getting 1 by x dx plus 1 by y dy plus 1 by z dz. Denominator is y square minus z squared plus z square minus x squared plus x square minus y squared. These two terms will get cancelled. These two and these two will be cancelled. So this implies 1 by x dx plus 1 by y dy plus 1 by z dz divided by 0. So I can write the numerator will be equated to 0. Plus 1 by z dz will be equal to 0. So now doing the integration part, I will be getting integral of 1 by x is nothing but log x. And integration of 1 by y is log y. Integration of 1 by z is log z. So I am going to take the integrating constant as log b. So first I am going to combine these two terms using logarithmic property. So log a plus log b is nothing but log ab. So xy plus log z equal to log b. This can be written as log xyz equal to log b. So finally our solution will be xyz is equal to b. This is our solution b. So the required solution, it can be written as pi of x square plus y square plus z square, comma, it is x, y, z. This is equal to 0. This is the solution of this problem. Take this next question, and this problem will be based on double multipliers. Okay, so this is capital P, this is capital Q, and this is capital R. So this is equation given in Lagrange's format. So the subsidiary equation is given here. Observe that whatever multipliers we may take, the denominator, it won't be equal to 0 because all the terms are given as positive terms. Suppose if I take 1 here, so I'll be getting 1 y plus 1 z. I have to put minus here. So if I'm having my negative this one, so here x should be positive. So I have to keep y as it is. So adding y and y, again it won't be equal to 0. So whatever term you can choose for multipliers, this denominator we cannot bring it as 0. So I'm going to choose one different method. Suppose you see both the terms, and what you can observe here, this z is common in both. And similarly, see these two terms, here x is common in both. Suppose if I subtract these two terms, that is dx minus dy, I can subtract the denominator also. It is y plus z minus x minus z. I will be getting these two things. So it is dx minus dy divided by, so I can take minus side commonly outside. I can write it as x minus y. Similarly, the last two terms we can write it as dy minus dz divided by minus y minus z. So in other words, it is nothing but choosing the multipliers as, so for the first one, this one we are choosing the multipliers as 1, minus 1 and 0. And for next last two sets, we are choosing the multipliers as it is 0, 1 and minus 1. So similarly, another one we are taking, I'm going to add everything dy dz divided by twice into x plus y plus z. Because if you add everything, there are 2x, 2y and 2z terms. So each fraction of 1 will be equal to, we can write it as dx plus dy plus dz divided by twice. That is equal to dx minus dy divided by minus x minus y and this term. So this is based on double multiplier method. In a single equation, we are using more than one multipliers. Okay. Now, I'm going to take the last two fractions. For example, I'm going to take these two fractions. So if we take these two fractions, you remember that this numerator can be written as d into x minus y. So if I bring that differentiation inside, it can be written as dx minus dy divided by minus x minus y. Here also I can write it as d into y minus z divided by minus of y minus z. So these two will get cancelled. So observe the term, the derivative of denominator is there in numerator. So it is nothing but we can write it as log of x minus y, and here it is log of y minus z plus I'm going to write an integrating constant log a. Bring this term here. So you will be getting log of x minus y minus log of y minus z. This is equal to log a. So after using logarithmic property and cancelling log on both sides, we'll be getting x minus y by y minus z is equal to a. So this will be our first solution u. So I have written that here. And then I'm going to take these two terms. First two terms. Okay. Taking first two fractions, observe that um, we can write first one as d of x plus y plus z divided by, we can take 1 by 2 outside, so it will be x plus y plus z. And second one, taking d commonly outside, it is this term by minus x minus y. Now we can do the integration straight away. Derivative of denominator is there in numerator, so we'll be getting 1 by 2 log of x plus y plus z. Here it is minus log of x minus y plus log b. I'm going to bring this term here, and since 1 by 2 is before log, I can bring this term to power of this one using logarithmic property. So this can be written as log of square root of x plus y plus z plus log of x minus y. This is equal to log b. Now using log properties, we can write square root of x plus y plus z into x minus y equal to b. So this will be our next solution b. So the required solution, it can be written as phi of x minus y divided by y minus z, comma square root of x plus y plus z into x minus y. This will be equal to 0. So this is a different type of problem using double multipliers method. And next one, see this question. So clearly this is capital P, this is capital Q. We have to take minus sign along for the term capital Q, and this one will be capital R. The first one, writing subsidiary equation is easy. We can write it as it is. And for the first solution U, I am going to use the grouping method. So I am going to take first two things, that is dx by y square equal to minus dy by xy. So y square and here y will cancelled, and I can bring both the terms. So one side, so it is x dx equal to minus y dy, and after integration we'll be getting x squared plus y squared equal to a. This will be our one solution u. Okay. And for the next term, I'm going to take the last two fractions. So taking last two fractions, dy divided by xy equal to dz divided by x into z minus 2y. Because observe that if we take last two fraction, and it is easy to cancel this two terms. So what I am going to do is cross multiply everything. So we can write z minus 2y into dy equal to y dz. So we can write it as minus dyz plus 2y dy equal to y dz. Now bring this term this side. So 2y dy will be equal to y dz plus z dy. Okay. Now observe this term. This is nothing but u dv plus v du. So this can be written as derivative of the product term y z. So now I am having 2y dy. This is equal to derivative of y z. So I am going to integrate on both sides. integrating of y will get y square by 2. 2 and 2 will get cancelled. So here, left hand side I'll be having y squared. On right hand side I'll be having yz plus some integrating constant b. So it is y square minus yz is equal to b. So I can take this one as my next solution b. Or we can take it as yz minus y square also. So the required solution will be phi of x squared plus y squared comma yz minus y squared. This is equal to 0. Once again observe that I have told you while deriving I am getting y square minus yz is equal to b, but here I have written yz minus y square equal to b. So observe one thing, we can change this sign yz minus y square equal to b. Now I can bring that minus sign to one side equal to minus b. I can take this as some other constant c or this one as solution. So while writing the solution, the sign it doesn't matter. So this will be the required solution. Thank you.